Good morning, friends. Once again, welcome to Enjoy Chemistry with Yash Private Limited. We are solving questions on thermodynamics, especially entropy change and free energy change. So, let's start with the first question of the day. For the following reaction, value of equilibrium constant is zero point 0.5 liter per mole. Calculate standard free energy of formation of C if those of A and B are minus 20.00 and minus 25.00 kilocalorie per mole. I hope you have noted down this question. Now let's focus on to the equilibrium constant first. Now look at its unit. It is given in liter per mole. So we should understand that they are talking about the equilibrium constant Kc. Okay. So and the units of free energy of formation are given in kilocalories, so we'll have to be careful when we'll substitute the value of universal gas constant R. We will put the value 1.987 and it's kilocalorie, so we will take care of this 10 raised to minus 3 also, right? Now look at this, it is given uh, liter per mole, so we can assume that these concentrations are in mole per liter, so this system will be in aqueous form. So let's frame first of all Kc. Kc is going to be concentration of C upon concentration of A upon concentration of B. So altogether in numerator it will be mole per liter and in denominator it will be mole per liter whole square. So that will result in mole per liter raised to minus 1 and ultimately it becomes liter per mole. It's clear? So our strategy should be, first of all, using the value of these 0.5 liter per mole, we can find out delta G0 value, and delta G0 will be the standard free energy of formation of product minus standard free energy of formation of a reactant, and that will give the answer to our question. Okay, so let's start our discussion. So okay, so our formula is delta G0 equals to minus 2.303 RT log Kc, right? Minus 2.303, it is 1.987 into 10 raised to minus 3. Why? Because it is in kilocalorie. Standard condition is mentioned, so it is 298 log Kc is log zero point 0.5. Now log 0.5 equals to 1 upon 2. So if I check the log of this 0.5, it will come in bar, and that bar will be again need to be converted into real negative number. So instead of doing that hassle, what I will do that instead of putting 0.5, that is log 1 by 2, I will convert it into log 2. So I think we know that log A upon B is nothing but minus log B upon A. So I will put log 2 and I will put as minus. So it will be minus 2.303 into 1.987 into 10 raised to minus 3 into 298 minus log 2. Why? Because this is log 1 upon 2. I will make it log 2, so it will be minus, and these minus and these minus will be now positive. And it is expected the answer of delta G0 should be positive. Why? Because value of equilibrium constant is less than 1, that indicates that the reaction is a non-spontaneous. Log 2 means log 2.000. Now if we check log of this, it will be 2.303 into 1.987 into 10 raised to minus 3 into 298 into it is going to be ये 20 का 0 और 0 में log चेक करें आप, कुछ log आप याद रख लें, it should be 3010, ठीक है। इसका सिंप्लीफिकेशन आप करेंगे तो इट इज 0.4106 किलो कैलोरी। दिस इज आवर डेल्टा G0। ठीक है, our equation is A opposite aqueous plus B aqueous reversibly C aqueous, ठीक है। चलो now delta G0 equals to sigma delta G0 F products minus sigma delta G0 F reactants, right? So we can have delta G0 F of C minus delta G0 F of A plus delta G0 F of B. So we have this value 0.4106 equals to delta G0 F of C minus this value is given to us, that is 20.00 plus 25.00. So this is 0.4106 equals to delta G0 F of C equals to minus 45.00. Is it? So delta G0 F of C is minus 45.00 plus 0.4106 equals to minus 44.5894. You can take as minus 44.59 kilo calorie per mole. Then so this is how you can solve. This part is very important. Let me explain you once again over here. Why? Because it is a log 0.5, that is log 1 by 2, that is equals to log 2, but that is minus log 2 as per this principle. Log a upon b is equals to minus log b upon a. So instead of log 0.5, you can put minus log 2. So this point is important. And of course over here there should be minus 20 and minus 25. Because in question they are given minus 20, right? Now we'll try to solve the same question in a reverse manner. Okay. The same question we are solving, and now we will find out the equilibrium constant. Note down the question. The standard free energy of formation of A, B and C are minus 20.00, minus 25.00 and minus 44.59 kilocalorie per mole. Calculate equilibrium constant for the reaction, that is A plus B reversibly C. So in this case, you can see the question that you are already given the values for A, B and C, and we have to calculate the equilibrium constant. So in this case it is not mentioned whether the substances are given in a gaseous state or an aqueous state. So we will consider that we are going to find just K, and we will not mention any unit of this K. Why? Because we don't know whether it is Kc or Kp. So our first step to find out delta G0 of the reaction. So delta G0 is equals to sigma delta G0F of products minus sigma delta G0F of reactants equal to delta G0F of C minus delta G0F of A plus delta G0F of B. Now the values minus 44.59, minus 20.00 plus minus 25.00 minus 44.59 minus 45.00 0 minus 44.59 plus 45.00, and it is positive 0.41 kilocalorie. The value positive, you can understand the reaction is non-spontaneous under standard condition. Now using these value, we will have to find out the value of equilibrium constant. What is the formula? Delta G0 is equals to minus 2.303 RT log K. We will put just K, right? Let's substitute the values. 0.41 equals to minus 2.303. It is in kilocalorie. So R will be 1.987 into 10 raised to minus 3. Temperature is 298 log K. So simplifying these as log K equals to minus 0.41 divided by 2.303 into 1.987 into 10 raised to minus 3 into 298 simplified as 0.3007. This is our log K. Now checking anti-log on both the side, we'll have to check anti-log of 30, 0, and 7, and this turns out to be यहाँ माइनस चेक कर ले एक बार. Somehow this is not working. Okay, but you should consider this minus over here, and I just restart this. You should consider this negative sign first of all, and then convert it into bar 1.6993. Now you can check the antilog of this. So 6993. It's 5003. This is your key. Got it? So you will have to be careful about this negative sign. So in previous question, the K was given to us. Now in this, you can solve it. So we will not apply any unit Y because it is not mentioned. Okay. Can we move? Okay. Our next question is standard free energy of formation for NO2 gas, NO gas, and O3 gas are 12.39, 20.72, and 39.06 kilocalorie per mole. And their standard heat of formation are 8.09, 21.60, and 34.00 kilocalorie per mole. Calculate standard entropy change for the following reaction. Calculate equilibrium constant for the reaction also. Equation is NO gas plus O3 gas reversibly NO2 gas and O2 gas. Now look at these values, these, and these. These are standard free energy of formation, means what? These are given delta G0F. And these values are standard heat of formation. These are what? These values are delta H0 of F. So we can find out this, we can find out this, and with the help of that we can find out standard entropy change. And with the help of these value, we can find out equilibrium constant. And you can see all the components are in a gaseous form. Our equilibrium constant will be Kp. Okay. So first we will find out about delta G0F. Okay. Our reaction is NO gas plus O3 gas reversibly NO2 gas plus O2 gas. The value of delta G0F as well as delta H0F will be taken 0 kilocalorie per mole for O2. Okay, delta G0 equals to sigma delta G0F of products minus sigma delta G0F of reactants equal to, it will be delta G0F of NO2 plus delta G0F of O2 minus delta G0F of NO plus delta G0F of O3. Now let's substitute the values. It is for NO2 it is plus 12.39, that of O2 is 0 minus that of NO is plus 20.72 plus that of ozone is plus 39.06. So 12.39 minus 59.78 simplified as minus 47.39 kilocalorie. Now delta H0 equals to delta H0 F of P minus delta H0 F of R, or simply you can write HP minus HR also. That is delta H0F of NO2 plus delta H0F of O2 minus delta H0F of O3 plus delta H0F of NO. Now we'll put the values. The value of NO2 is given plus 8.09 plus this value will be 0 minus O3 value is 34.00 plus 21.60, is it? This is simplified as 8.09 minus 55.60, resulting as minus 47.51 kilocalorie. Now as we have both the values, we can substitute in the formula. That is delta G0 equals to delta H0 minus T delta S0. Delta S0 rather T delta S0 is delta H0 minus delta G0. So delta S0 equals to delta H0 minus delta G0 upon temperature equals to, we have the value that is minus 47.51 for delta H0 minus 47.39 upon temperature is 298, and of course we will show this in calorie, so this entire should be multiplied with 10 raised to 3. Why? Because the values of delta H0 and delta G0 are mentioned in kilocalorie. Okay, so you can simplify these as minus 0.402 calorie Kelvin inverse. Precisely 4027. Okay, let's move on to the next question. Standard heat of formation of NO2 gas and NO gas are 21.60 and 8.09 kilocalorie per mole. Standard entropy of NO2 gas, NO gas and O2 gas are 50.3, 49.0 and 57.5 kilocalorie, calorie per Kelvin mole. That is calorie, Kelvin inverse, mole inverse. You have to find out all terminologies like delta H0, delta S0, delta G0 and Kp. Why it is Kp? Like this. Okay. But for previous question, let's first of all find out delta G0 we have already solved. We can find out equilibrium constant Kp also. That is minus 2.303 RT log Kp. Now it's minus 47.39 minus 2.303 1.987 into 10 raised to minus 3 into 298 log Kp. So log Kp equals to 47.39 divided by 2.303 1.987 into 10 raised to minus 3 into 298. So it turns to be 34.7 7519. Now we'll check the antilog of this. Is it 5648? This becomes the power. Now think of unit, it will be unit less. Why? Because you can check the equation. In numerator it will be atmosphere square, and in denominator also it will be atmosphere square. So it will be unit less. This is your answer of K. Fine. Now let's move on to the next question. Okay, hope you have noted down the question. We will start with, first of all, delta H0F. So delta H0 equals to delta H0F of products minus delta H0F of reactants, right? And it goes like 2 times delta H0F of NO2 minus 2 times delta H0F of NO plus 1 time delta H0F of O2. That is 2 times value of 2 into 8.09, 2 times positive minus 2 times 21.60 plus 0. Hope you have noted down the question, right? Just to correct the values, this you should correct these as NO, and this value is NO2. and in this also this is NO. This value is for NO, this value is for O2, and this value is for NO2. So in this it should be NO, O2 and NO2. So make the correction. NO, NO2, and here NO, O2 and NO2. Okay. Now same we will do for entropy change. Delta S0 is equals to SP0 minus SR0. That is now 2 times S0 of NO2 minus 2 times S0 of NO plus S0 of O2. So the values are 2 times 57.5 minus 2 times 50.3 plus 1 time 49.0. 115.0 minus 100.6 plus 49.0, that is 115.0 minus 149.6, that is equals to minus 34.6 calorie Kelvin inverse. Delta G0 equals to delta H0 minus T delta S0 equals to minus 27020 minus 298 minus 34.6 equals to minus 27020 minus plus, resulting as simplified as minus 16709.2 calorie equals to minus 16.71 kilocalorie आप ले सकते हैं. Now delta G0 equals to minus 2.303 RT log Kp. The value is minus 16709.2 equals to minus 2.303 into 1.987. I'll keep this 1.987 only क्योंकि मैंने यहाँ पर कैलोरी ही रखा है. 298 and log Kp. So log Kp equals to 16709.2 divided by 2.303, 1.987 and 298 equals to it is 12.2531. Now if we check the antilog of this, 2531. It comes 1791. Into 10 raised to 12. Now our equation is twice NO gas plus O2 gas reversibly twice NO2 gas. So Kp will be P of NO2 square upon P of NO square into P of O2. So it will be atmosphere square, atmosphere square, atmosphere. So it will be atmosphere inverse. So your unit will be atmosphere inverse. Clear? Okay. Next question. Standard cell potential for the reaction given below is 1.10 volt. Calculate standard free energy change and equilibrium constant for the following reaction. Now look at the question. You are given standard cell potential, that is 1.10 volt, and we have to find out the equilibrium constant for this reaction. Now what should be the scheme? That delta G0 is minus NFE0 cell. Now E0 cell is already given, F is known, that is a Faraday constant. Now we need N. N is the number of moles of electrons cancelled on opposite side. And for that you are given a reaction. You should take care that this reaction is found balanced in this, but it may not be given balanced in all the questions. So let's find out what is oxidation and what is reduction. Zinc is 0, copper is plus 2, copper is 0 and zinc is plus 2. So zinc becomes zinc plus 2 is oxidation, and plus 2 becomes 0 is reduction. So Zn becomes Zn plus 2 is oxidation, and that occurs at anode, and Cu plus 2 becomes Cu is reduction, and that occurs at cathode. Okay, can we start the question? Okay, so what happens at anode? Anode oxidation takes place. Zn solid reversibly Zn plus 2 aqueous and 2 moles of electron. At cathode Cu plus 2 aqueous if you want to write the overall reaction, that is considered as overall cell reaction, these 2 moles of electrons will be cancelled. So number of moles of electrons cancelled are 2 moles. So N equals to 2 mole. Now we'll substitute this value in the formula. N equals to 2, F equals to 96500, and E0 cell is 1.10. It is minus 212,300 volt coulomb, and we know that volt coulomb is nothing but joule. Now delta G0 equals to minus 2.303 RT log Kc. Why Kc? Only because zinc and copper are in solid form and Zn plus 2 and Cu plus 2 are in aqueous form. So ultimately the equilibrium constant will be Kc. Minus 212,300 equals to minus 2.303 into 8.314, temperature 298 log Kc. This is in joule, so this remains 8.314 only. Log Kc equals to 212,300 divided by 2.303, 8.314 into 298. So it is 90 log of 27.4. I'll check Kc. Kc will be equals to Zn plus 2 concentration upon Cu plus 2 concentration. This is mole per liter, this is mole per liter, so ratio will not have any unit. So this will be unit less. Okay, next question. Note down the question. Standard cell potential for the reaction given below is 0.46 volt. Calculate standard free energy change and equilibrium constant for the reaction. So in this case, the values given to you is E0 cell 0.46 volt, and you can see in this case the equation is given not balanced. We'll have to balance. Copper is 0, Ag is plus 1, Cu is plus 2 and Ag is 0. So copper undergoes oxidation, Ag plus undergoes reduction. Now number of electrons involved in copper reaction will be 2 mole. electrons, and Ag plus 2Ag will involve 1 mole electron. So we will have to multiply cathodic reaction by 2. What happens at cathode is Ag plus becomes Ag. I will multiply it with 2 directly. Now the overall reaction, or you can say cell reaction, in which 2 moles of electrons will be cancelled. So in this also N equals to 2 moles. Okay, let's move. Now delta G0 is equals to minus NF E0 cell. N equals to 2, F equals to 96500, and E0 cell is 0.46. And it comes minus 88780 volt coulomb, and that is minus 88780 joule. Now delta G0 equals to minus 2.303 RT log Kc. In this also it will be Kc, right? Now minus 88780 equals to minus 2.303, that is 8.314, and temperature is 298 Kelvin, log Kc. Now log Kc equals to 88780, 2.303, 8.314 into 298 equals to, it comes 15.5595. Now antilog of this 5595. Is it 3626? into 10 raised to 15. Now Kc is Ag plus concentration, sorry, Cu plus 2 concentration upon Ag plus concentration square. So this comes mole per liter, this comes mole per liter square, so it will be mole per liter inverse. So unit mole per liter inverse, or you can write liter per mole also. Check it. Okay. Next question. Standard cell potential for the reaction given below is negative 3.87. Calculate standard free energy change and equilibrium constant for the following reaction. Mg solid plus Au plus 3 aqueous, reversibly Mg plus 2 aqueous plus Au solid. Now you can see in this Mg is 0, Au is plus 3. I think we need to correct this, it should be positive. Correct this, it should be positive 3.87. Mg is 0, Au is plus 3, Mg is plus 2, and Au is 0. So magnesium undergoes oxidation at anode and Au plus 3 undergoes reduction at cathode. Now number of electrons involved in oxidation reactions are 2 and number of electrons involved in reduction reaction are 3. So oxidation reaction should be multiplied by 3 and reduction reaction should be multiplied by 2. Then we can have number of electrons in both the reaction same. Okay. Now anode. I will write 3 Mg solid reversibly 3 Mg plus 2 aqueous plus 6 moles of electron. Cathode twice Au plus 3 aqueous plus 6 moles of electron. Reversibly twice Au solid. Now the overall reaction या तो cell reaction. It will be 3 Mg solid plus twice Au plus 3 aqueous These 6 moles of electrons are cancelled on both the side. 3 Mg plus 2 aqueous and twice Au solid. Now in this case number of moles of electrons are 6 mole. The value of equilibrium constant is going to be very high in this case. Let's see. Of course, delta G0 value will also be very large. Delta G0 equals to minus NFE0 cell. That is minus 6 into 96500 into 3.87. I hope you have corrected. This is positive value. And the value comes very large. That is minus 2240730 volt coulomb. That is minus 2240730 joule. Okay. Delta G0 equals to minus 2.303 RT log Kc minus 2240,730 equals to minus 2.303 into 8.314 into 298 log Kc. So log Kc equals to 2240,730 2.303 8.314 298. And the result is 392.7076. You can understand it's a very large value. Now anti-log of this 7076. Eight four nine eight. So 8.498 into 10 raised to 392. You can see the power. So it's a powerful power. Now come to the unit, right? See the equation. Should I write Mg plus 2 concentration cube upon Au plus 3 concentration square? So this is mole per liter cube, mole per liter square. So this results in mole per liter. By mistake I have checked the law. This is wrong. It should be 5100 into 10 raised to 392. Okay, this is wrong. Correct it. Okay, so thanks for the day. We'll continue in next class. Thank you.